Hello, thank you for watching this video. So in this video, we're doing question 9 of November 2021, question paper mathematics paper 2. And the topic is the Euclidean geometry, as you can see over here. So let's go. They are saying in the diagram, PQRS is a cyclic quadrilateral. PS is reduced to W. TR and TS are tangent to the cycle at R and S respectively. They went on to say, angle T is equal to 78 degrees and angle Q is equal to 93 degrees. So let's have a look. They are saying PQRS, this quadrilateral here, is cyclic, right? And then they wanted to say that PS, this side PS of this cyclic quadrilateral PQRS is extended. This side PS is extended to W, as you can see. So SW is an extension of PS. So this is a direct straight line. That's what that means. They went on to say that TR, where is TR? TR is a tangent to this circle at point R, and TS is a tangent to this circle at point S over there. They went on to say that angle T is equal to 78 degrees, so this angle here is equal to 78 degrees, and angle Q is equal to 93 degrees. Fine. So we might need to discuss a few things, but you can watch my bad actions sessions, right? If you can go to my playlist and watch bad actions, you will find I've taught this, all of it, right? From the beginning up to tangents. So I've did all of this. Fine. So at 9.1, what are they saying at 9.1? They are saying, give a reason why ST is equal to TR. So they want us to give a reason why ST, which is this length over here, is equal to TR, which is this length over here. So they are saying, give a reason why ST is equal to TR. So they want us to say why ST is equal to TR. They want a reason for this. So you know that TS and TR are tangent to the circle, right? TS and TR are both tangents to the circle. So if you have, for example, if you look at this point T, you can only draw two tangents from this point to this circle over here. So one will be TR and the other will be TS. So if you have a point, you can only draw two tangents to a circle, right? Fine. So what you need to understand is that if you draw, since I'm saying from one point, you can draw exactly two tangents to a circle. Those two tangents will also be equal in length. So if you have the point T here and TR the tangent and TS your tangents, those are the only two tangents that you can draw from that external point. Even if you have another point here, you can only draw two tangents coming from that one point. And those two points and those two tangents will be equal in length, which is the length between the point, which is the outside point or the same point, to the point of tangency, and the length from that same point to another point of tangents. Those lengths will be equal. Those lengths will be equal. So in this case, the reason ST is equal to TR, because these are the tangents from the same point. So you need to know that the tangents from the same point are equal in length. The tangents from the same external point are equal in length. So they want us to give a reason why ST is equal to TR, because those are tangents from the same external point, which is from the same common point. That is the reason for it. So you need to always keep in mind that if you have a point, if you have a point and a circle, from that, if you have an external point, which is an outside point and a circle, from that external point, you can only draw exactly two tangents, right? And those two tangents will be equal in length. So the tangents from the same common point are going to be equal in length. So the reason for this, we will say, we have what? These are tangents, right? Tangents from same external point, which is outside, external, which is outside the circle point. So these are the tangents from the same external point. So the tangents that are drawn from the same external point will be equal in length. We're done. So in that case, we can add that information there and say, okay, now we know that this length over here is equal to that length over there. We're done. So we move to the next question, which is 9.2. What are they saying in 9.2? At 9.2, they are saying, calculate giving reason the size of angle S2. So at 9.2.1, they want the size of angle S2. They want us to find the size of that angle, S2. Where is angle S2? S2 is this angle over here. So this angle S2, if you look at it, it is inside this triangle. What kind of triangle is this? This is an isosceles triangle. An isosceles triangle is a triangle in which exactly two sides are equal in length. So your ST is equal to your TR, as we have said here, because those are tangents from the same external point, right? So therefore, we have an isosceles triangle STR. And what you need to remember, if you have an isosceles triangle, let's say you have three angles here, this angle, and that angle here. So this angle is facing this side, and this angle is facing this side, and this angle is facing that side. So the angles that will be facing, or that will be opposite equal sides, are also going to be equal in measure. So if you look at your R2 and your S2, they are both facing those two equal sides of an isosceles triangle, which is these two angles are also equal in length. So that's one of the properties of an isosceles triangle. So in that case, what we're going to say, okay, in triangle STR, right, we're going to say our ST is equal to TR. Why? There's a reason. These are tangents from same external point. That is my reason. These are tangents from the same external points. Therefore, this is an isosceles triangle, right? In that case, which is your angle S2 would be equal to your angle R2. Why? These are angles that are opposite, equal sides of your isosceles triangle. So in that case, we want this angle. So we know that if you add S2, R2, and angle T, that will give you 180 degrees, because those are interior angles of a triangle. So in that case, we'll say, okay, angle S2 plus angle R2 plus angle T, this will give us 180 degrees. Why? This is the sum of angles in the triangle, or those are interior angles of the triangle. So in that case, because S2 and R2 are equal, we are looking for S2. So in the base of R2, we can put another S2. So we'll have angle S2 plus another angle S2 plus angle T, which is 78. This is equal to 180 degrees. In that case, we're going to have what? We're going to have two S2s, right? Is equal to what? Is equal to 180 minus 78, which looks like something like 102, right? Then divide by 2, divide by 2. You get that your angle S2 is equal to half of this, which is about 51 degrees. So we're getting that angle S2 is equal to 51 degrees. So what we have here is 51 degrees, and this one is also 51 degrees, because these two angles are equal. We're done with S2. So we're done with 9.2.1. Now we'll move to 9.2.2. What are they saying in 9.2.2? At 9.2.2, they are saying, calculate giving reasons the size of angle S3. So they want us to find the size of angle S3. Who is angle S3? Angle S3 is this angle over here. Angle S3 is this angle over here. Fine. Look, if you look at S2 and S3, you'll quickly discover that these are exterior angles of a cyclic quadrilateral, right? These two S2 and S3 are exterior angles of a cyclic quadrilateral. So, you know, you can go and watch my bad actions if you don't know this, because I did teach this. An exterior angle of a cyclic quadrilateral is equal to the interior opposite angle. So you know that if you add S2 and S3, they should give you your angle Q, because that is an exterior angle of a cyclic quadrilateral. Right? So go and watch my bad actions, then you'll understand what I'm talking about. So in this case, we can say angle S3 plus angle S2, they'll give us angle Q, because these are exterior angles of a cyclic quadrilateral. And you know, like I taught on the bad actions, that an exterior angle of a cyclic quadrilateral is equal to the interior opposite angle, which is, this is an exterior angle of a cyclic quadrilateral. It's going to be equal to the inside opposite angle of your cyclic quadrilateral. So in that case, say S3, angle S3 plus angle S2, which is 51 degrees, is equal to 93, right? So you get that the angle S3 is equal to 93 minus what? Minus 51, which looks like it should be something along 42 degrees. Right? And let's just double check our answers. So 80 minus 50 minus 78 over 2. Yeah, this is 51. So in that case, 93 minus 51. Yeah, it is 42. So this is how I would have done this 5 marks question. And I'm done with this. So if you found any of this unclear, there is a solution. Go to my playlists and look for bad action sessions. I did teach this. And I'm done here. I hope it does make sense to you, as it does to me. So I'm going to move to question 10. So let's go to question 10.